AC method, AC grouping method. I originally learned it as AC, so I'll often refer to it as just the AC method. Other places call it grouping, and like I said, sometimes AC grouping is what's used. Alright, here's the procedure. Multiply the A and the C. Find the factors of A and C. You want to list them as factor pairs, and we've already talked about finding the factors of numbers and the reason to use the factors pair process. Then you want to find the set of factor pairs that add or subtract, depending on the sign of C, to equal B. Then you rewrite the B term with those factors, putting the signs in place just like we did for the trial and error. The larger factor gets the same sign as the B. The other one is the same if you're adding, opposite if you're subtracting. Then you factor by grouping, hence the name AC grouping, because we're going to be multiplying AC at the beginning, AC multiplication, and then we're going to factor by grouping at the end. So the process, the name of the process tells you what to do. AC grouping method. For example, let's use 6x squared plus 7x minus 10. Multiply the A and the C. In this case, 6 times 10 is 60. Notice I don't care what the sign is. 6 times 10 is 60. Find the factors of 60. That is the only number we need to find a factor of. We're not going to reverse any list. We're not going to have multiple lists. We have one list of the factors of 60. Factor pairs 1 through 6 on the left side consecutive, and then whatever they divide out to be on the right side. Simple, quick, easy. Then we pick the set of factors that subtract, because we have a minus sign up there, to equal 7. Notice the sign on the C is subtraction, and we want to equal 7. When we do our factoring with this method, we're going to read backwards from right to left. So we multiplied A times C and got 60. Then we want the factor pair that subtracts to equal 7. Okay? And that's going to be the 5 and the 12. There's only going to be one that works. And it's going to be one on a relatively short list. Just 5 and 12. We rewrite the B term using the correct signs. So instead of 7x, we want to use the 5x and the 12x. The larger factor gets the same sign as the B. The other factor gets the opposite in this case because we're subtracting. If we had been adding, if this had been plus 10, then we would have been adding, and we would want both factors, both signs here, to be the same. However, since we were subtracting, then they need to be opposite. The larger of the two gets the same sign as the B, the other one is going to be opposite. Then we factor by grouping. There's a common x in the first group, leaving us with a 6x minus 5. A common 2 in the second group, leaving us with 6x minus 5. So that common 6x minus 5 comes out to the left, and we get the 6x minus 5 times x plus 2. And we can check that quickly and easily by foiling it all back together, and we will end up with 6x squared plus 7x minus 10. Now, please tell me that you recognize that this is much quicker and easier than the trial and error method. But there's better than that even. The shortcut method performs steps 1 through 4 exactly like the AC grouping method. We're going to multiply A times C, find the factors of that result, and we're going to pick the set of factors that adds or subtracts to equal B. But the difference is now, instead of rewriting the B term, we're going to go straight to parentheses. In the parentheses, we'll put the A coefficient as the first term in each binomial. Then we'll put the factors for the second terms into the binomials, just like when we rewrote the b term. We're going to use the factors from the factorization of AC. And then we put the signs in the exact same way. The last step is to reduce the binomials by anything that's common, and here's the clue. Here's a hint to make sure you're doing it right. Whatever you reduce out down here is going to equal the extra a that you put in there. Say a is the number 3. You would have put in an extra 3 in both of the binomials, and you'll throw out a 3 at the end. If a was 12, you'll put in a 12 in front of each binomial, and then you'll throw out a total of 12. It could be 12, it could be 2 and a 6, it could be a 3 and a 4, but one way or the other, you're going to throw out a total of 12. Let's see that in action. We'll use the same polynomial so that we can compare apples to apples. 6x squared plus 7x minus 10. Again, the first 4 steps are exactly the same. We multiply a times c and get 60. We factor that out. We get the factor list. We pick the pair that subtracts to equal b. Now we come to what changes. We're going to go straight to parentheses. We're going to put a 6 in front of each binomial, right, the a term. Then we're going to put the factors that we got in for the second term of each binomial. The larger one gets the same sign as the b. The other one is opposite because we're subtracting. See that up there. Okay. Then we're going to reduce any commonality. You should recognize already the commonality of 6 and 12. We can get a common 6 to come out of there. Cross that out, and we get x plus 2 instead of 6x plus 12. And that's it. It's done. We put an extra 6 in, we threw a 6 out, and we're left with 6x minus 5 times x plus 2. That will work anytime that you have a factorable polynomial. Not all trinomials are going to be factorable. If it's factorable, this will work. If it's not, we have other things to do later. Alright, that's if the trinomial had an a term. If it doesn't have an a term, it's actually even quicker and easier. It's essentially the same process, though. You got the standard quadratic form, ax squared plus bx plus c, where a, b, and c are coefficients. In this case, there's no a term because the a is in fact going to be 1. Procedure, 1 through 4 are exactly the same. Except when you multiply a times c, 1 times c is going to be c. So all you really have to do is start with the c and go backwards. Find the factors of c that add or subtract to equal b, and then go straight to your parentheses. There will be nothing to reduce because a is 1, and so putting a 1 in front of each of the binomials is not going to have anything left over to reduce. For example, x squared minus 7x plus 10. Start with the c, the 10. Find its factors. Pick the pair that adds to be 7. Go to your parentheses, fill them in. We get x and x for the start of each binomial, 5 and 2 for the end of each binomial. The larger one gets the same sign as the b. The other one is going to be the same because we were adding. That's it. If we FOIL that out, we end up with the same thing that we started with, x squared minus 7x plus 10. When there's no a term, it is extremely easy. Start with the c, factor it, pick the factor pair that works, put them in your parentheses. Boom. That's it.